giving the information. Am I audible?
Hello. Uh,
Yeah.
Sir, your voice is little bit
Okay.
less.
Just give me a minute. I will change the.
All right. Am I audible now?
Yes, sir, you are audible.
Thank you for the confirmation. Also, thank you for the warm welcome from everyone. Just this. Is my screen visible?
Yes, sir, it is.
Yes. Thank you. So, yeah. So today, first of all, we are going to talk about the foundation of generative AI itself. Like now, we use this technology on in our day-to-day life, but if we see a couple of years ago, presumably around 2019. Of course, these technologies became quite popular after 2022, but they have been there like from 2018 itself on a larger scale. But prior to that, we were not able to use that or make use that for building various chatbots or even various generative AI application which you see nowadays. Now, considering going back into the history a little bit, now when we consider the AI, so the AI, the term itself has been around from 1950s itself. It was first coined in 1957, but you will see the extensive use or even the progress of AI started to happen after a lot of time, like 2010 itself. So there were two reasons. First of all was the data itself, and the second one was the compute power. Because uh, because without these things, whatever state of AI we are in now, we wouldn't have been there. Okay. Of course, when we say a lot of data, so the data would be in zettabytes itself. If you see the statistics, then by 2010, you had around 20 zettabytes worldwide data available, but that increased to 181 zettabytes uh, in just 11 years by 2021. So the sudden increase in the data was because of the digitalization of our world itself. And because of that, these AI systems, or basically which originate from machine learning itself, they utilize this data to learn for themselves. Now, over here, after the initial success in machine learning itself, you also had the another field of AI, that was deep learning. You can consider it as a subset of AI itself. If you see in old days, in before prior to 2000, you had AI systems, which also called as expert systems. So those were generally rule based AI systems. You had a lot of implementations at that time, but there was much limitations in that system. And later on, machine learning came into the picture. Over the years, it got popular, and later on you had these deep neural network, where the architecture of these network itself, we try to imitate our human brain. But even though when we are saying imitating human brain, it is not like we have completely imitated the human brain or the working of the human brain. It was just a try. It is still the same case, by the way. Now, uh, first of all, we'll see what is the difference between generative and the discriminative AI, which we generally used to use before prior to 2017. So also along the way in the session itself, if anyone has any doubt, any question, please let me know. If you didn't understand a particular topic or particular you have a particular query, you can ask. Okay, I will try my best to answer your queries as well. So, generative AI, as the name suggests itself, these are the algorithms that can generate new content. Now, when we say generating new content, primarily when it originated, okay, the content was generally the text itself. But nowadays, you can see that not only text, but you can generate new images, new music, even new videos, and multiple modalities are there. Okay, modalities means the format of the files based on the training data. It operates on the principle of learning patterns and structures from the existing data to create new similar output. So what it generally does is basically trying to learn the patterns which are existing in its training data, whatever data it has been trained on. And based on those patterns itself, it learns to generate the similar outputs. Okay. Here, when given a prompt, generative AI uses this statistical model to predict what an expected outcome might be, and with this, it generates the new output. Now, prompt is also one very important factor because what you generate, what kind of response you get, be it image, be it your text, or any other format, it majorly depends on the prompt you're giving to your AI model. Okay, so prompt is kind of like an input which you give to your generative AI model, and in return, it generates a new response based on your prompt. Now, these AI models are also not something like magic. They are also called as statistical models, same as you have in machine learning or neural network. It just the sophistication of these models is a lot more as compared to them, and because of the advancement in the various different kinds of architecture of these models, you are able to get better and better response. And in today's landscape of AI, you will see like all these major AI companies, be it Anthropic, be it Google, be it your OpenAI or any other, even your Chinese companies. So all of them are kind of having the major AI race in between them, and every company is actually trying to get ahead in this particular race. So if you see that artificial intelligence is a broader field, machine learning is the subset of it. If you go further in the machine learning, then you will have deep learning, and you can consider that generative AI, even agentic AI, is nothing but the combination of the subset of machine learning and deep learning itself. When you are building it, you will see a lot of the concepts are basically originating from the machine learning itself. Okay, so when we consider the difference between a discriminative and generative model, so in discriminative model, these are generally used to classify data. Now, if I'm sure some of you might be familiar with the traditional machine learning itself. So, considering our structured data or our supervised learning. In supervised learning, whatever model we were using, be it logistic regression, be it our decision tree or anything. Okay. So, we were trying to build a model on that so that we can use that labels as well as the input to train our model so that it will, upon similar experiences or similar input, it will give us the output later on. So over here, we were basically trying to learn the decision boundary between different classes. And if we talk about in terms of probability, so they predict labels given the features, means in inputs, and focus on probability of y given x, means what is the probability of this particular output given these features are occurring. So that is what discriminative models are. So in discriminative models, you can understand that whatever outcome you are going to get, that is going to be deterministic, means whatever, let's say you have five set of labels, so whatever output you get, that will be from those five set of labels itself. Okay, nothing else. Now over here in generative models, they try to uh, aim to model the joint probability between the distributions, means it tries to check like what is the probability of different words given a particular statement or particular prompt has been given. They can generate new data points, making them suitable for applications like image generation. Okay. Now, if you see a bit history of generative AI, You can see the ideas of creating content that's back in 1950s. But also, as we say, these ideas are like way old from 1950s. The first AI implementation, or you can say first chatbot, was actually implemented in 1966, called as Elisa. Okay, of course, it was not that you can say as capable as what models you see nowadays for the chatbot or for text generation, but nevertheless, it was the first implementation to create a chatbot in 1966. Now, in 2014, people, various scientists actually introduced another architecture called as GANs, or Generative Adversarial Networks, by Ian Goodfellow. Now, this in 2014 was kind of like first attempt, you can say, among multiple attempts were there prior to this as well, but you can say this was the most successful. So in 2014, they introduced this GAN architecture, which was actually used for generating various images. Generating various images. So generative AI came into the picture in 2017 when we are considering computer vision itself. But you will see it was much later in 2017 that we were actually implement generative AI for natural language processing. Okay, for natural language processing. So anyone can give me the like reasons that what could be the reasons that even though we were able to use it or have generative AI for computer vision, but for NLP we had to kind of wait 3 years itself. What were the reasons that we could not do it before or prior to the 2017? You can put your answer in the chat box as well. Just a second. You can put your answer in the chat box as well. Hopefully everyone has access to type the message there. So if you have any answer to this, like why was it that we were not able to implement generative AI in natural language processing? So yes, Gajanan, you said might be due to different types of handwriting. That could be one reason because considering the nature of natural language and the various handwriting of human beings, so a particular text can be written in multiple ways considering the handwriting. So it increases the complexity of the data, and which makes it a lot of like unstructured way. Correct. So grammar. Not exactly grammar because priorly like in natural language processing you will see various implementation like named entity recognition and stuff. Even you were able to use uh, machine learning for various kinds of NLP tasks as well. Because of big data, the data is generated in large amounts that can be used in the model. Yeah, I mean, compared to like 2014, 2017 obviously had a large amount of data, but still data like in around in 2014, 15 would be even sufficient at least for like the starting implementation. Because if you see these models we had, they at the start itself were not that great. Slow by slow, little by little, they started becoming better. Risk of hallucination. Hallucination is actually a completely different thing. Okay, I'll come to that. What exactly it is, and we are having to process to run those models. Not exactly, because obviously, as compared to NLP, if you try to process image data, you will see the learnable parameters which we will be having will be more on image data. So, yeah, like that. Of course, nowadays bigger and larger models are coming, so they need this large amount of processing power. But what I mean to say, maybe not build a really good model, but at least the implementation, a good implementation was not there. All the answers are really good, by the way. Anyone else wants to add? All right. So there were a couple of reasons. Okay, just a second. So there were a couple of reasons. Did someone answer? NLP needs pre-processed data, huge feature set. Yeah, yeah. That could be one. Okay. So the major problem of generative AI was that many of the reasons you have already given. Uh, don't mind if there's a little bit of background noise beside me. So anyway, so one of the reason was that when we are considering images, okay, so the data is kind of structured, and when we talk about convolution neural network, then convolution neural network did a great job at restoring or getting that spatial representation, spatial information of the images in early days itself. Later on, you will see there were various models of CNN like ResNet, AlexNet, okay, like that. Uh, and you also can see that the concept of transfer learning was, we were able to implement that in uh, the field of computer vision itself. So the concept of transfer learning is, by the way, where you train a particular model on the very, very huge data set, maybe kind of like internet data. And later on, if you want to solve a similar use case, instead of building a particular model from scratch, you can use this pre-trained model. You can fine tune it on your data and use for whatever use case you may have. That is what transfer learning is. Okay. So you were able to implement this transfer learning there. Okay. So now coming to 2017, what problems transformers or why we were able to implement it. Okay. So the way prior to transformers, the state of the art, or you can say for NLP, the most advanced models or architectures were encoder decoder. But even when we say encoder decoder architecture, the fundamental unit in that were LSTM and GRU. Okay, so if you are familiar with artificial neural network, then in LSTM, that is long short-term memory, or GRU, Greater Recurrent Neural Network, these were the type of neural networks which were used in sentences. Okay, but as compared to sentences, okay, where we, let's say, had images. In images, the sequential data or sequence isn't that much important. But whenever we are trying to consider the sentence, okay, the sequence matters a lot. So that is why so far in neural networks we needed to maintain the sequential data or their time dependency we needed to maintain. And LSTM GRU did a great job at that. That when we were passing the input in time-wise manner in multiple time steps, it was able to learn it. But the problem was there because in neural network we have something called as gradient descent. Okay, and in this gradient descent, we basically try to make the loss lower and lower, and we try to calculate gradients to do that. So because of the time dependency, we needed to pass the data sequentially whenever we considered our passing or giving the training data to our some NLP model like LSTM or GRU. Okay, that was not the case in terms of computer vision models. So be it CNN or any other architectures. So there you could give the data directly parallelly as well as compared to over here. And because of that, when you're passing the data in sequence, you these models were having problems with your vanishing and exploding gradient. Okay, and because of that, let's say if you give your sentence, which is, let's say, more than of 45 50 length of words or something, so it started forgetting it. Okay, it started forgetting it. So that is the problem with vanishing gradient. Okay, so in transformers, what they did, if you look at the architecture of it, okay, just a second. Just keep the architecture in front of you. So over here, you can see the architecture of a transformers. Okay, so I'll explain, give you an overview, like, what each layer basically does. So don't be intimidated by it. Even though the architecture looks complex, if you understand it by component, so it is fairly easy. Okay. So the way Transformers was designed in 2017. So researchers from Google DeepMind had the paper called as "Attention is all you need." Okay. So over here, the way we were passing our inputs, okay, our input data or training data, it was parallel processing. Okay, it was the parallel processing. So because of this parallel processing, what happened that even if you had very large amount of data, okay, you could train your model on that, because obviously when you wanted to do it sequentially, okay, so the amount of compute itself will be very very huge to in order to process all of that. So over here all the data was getting passed parallelly. Okay, but obviously at one thing side we are saying that in text the sequence matters, but here we are passing all the data parallelly, right? So that is also why we needed to introduce something, so that even if we are passing the data parallelly, our model should know that which word is coming first, which word is coming later on, all that thing. Okay. So that is why the component you are seeing over here, the positional encoding, it is used. So what positional encoding does, so it introduces periodic function, so that even if you're passing your data parallelly, your model will be able to understand the sequence of those words. Okay. So this was the first reason, and because of this, transfer learning became easy. Okay. Of course, later on there was one more paper after like couple of months of transformers itself, called as ULM fit, which proposed transfer learning for natural language processing. Okay. Now another problem which transformers solved is called as self attention. Okay. Self attention was the solution to that problem. So in self attention, so far, by the way, whenever we consider natural language processing, uh, these computers, our systems, are not able to understand the text data, right? But they are able to understand the numbers. So we have to convert our numbers, or sorry, we have to convert our text data into various numbers. Okay. So priorly in machine learning, you will see there were methods like one-hot encoding was there, bag of words was there, even your GFIDF was there. All of them were great techniques still being used in many of the domains. But these techniques were based on the frequency of the words. Means how many number of times a particular word is appearing in your corpus. Based on that, the importance was decided and stuff. Okay. They were not able to understand the semantic relationship itself between the words. But later on, around 2012, Google again, like, published a couple of papers and models, something called as continuous bag of words, or more precisely, word embeddings. So in word embeddings, they introduced two models. Later on, you will see like multiple models are there. The primary models were continuous bag of words, and later on, your skip gram. Okay. So word embeddings became really popular within short duration because these were not based on the frequency of the words. Here, through word embeddings, your models were able to understand the semantic relationship between different words. What does that mean? That let's say if I have embeddings of the word, let's say dog and cat. So model will understand that when I'm having these embeddings, dog and cat, then they are like very close to each other, considering both of them are animals. Okay, so if I consider plotting their word embeddings into multidimensional, let's say vector space, you will see that vectors will lie very close to each other. Okay, and you will see word embeddings dominated entirely for next 5 to 6 years. Okay, from the time they were introduced, but they had very huge problem. What was the problem? That, sorry, just a second. The problem was, let's say if I have couple of words. Okay, let's say I had a I ate an apple, and another sentence I have, I used an apple. Okay, over here you can see that there are two sentences and the apple word is coming over here, right, in the both sentences. But is the context of the apple for the both sentences similar, same? No. Over here at one particular place, the apple over here is, we are using it in a context of a fruit. Another one, we are using it in the context of a device. Okay. But what word embeddings did, it created the same embedding for apple and same embedding for this particular apple as well. But obviously, if the embedding is same, then model will be understanding the same meaning of it. So this was the problem in prior mediums. In transformers, they introduced something called as self-attention. Although instead of self-attention in the architecture, you will learn or see the word multi-head attention. So multi-head attention is nothing but multiple self-attention on top of each other. That's it. Okay, nothing else. So in self-attention, what were we able to accomplish is that instead of having static embedding means same embedding for this particular word, if even if it is appearing multiple times in a particular sentence. So instead of static embeddings, we were able to get dynamic embeddings. And through these dynamic embeddings, your model was able to actually understand that a particular word is used in a particular context. Okay, particular word was used in a particular context. So that is the problem, one of the major problem which transformers solve. So over here you can see multi-head attention. Okay, so once this problem got solved, by the way, researchers at that time who published the paper, they themselves did not know, did not think that it will completely change the landscape of your AI. Okay, after a couple of years, in in the next 5 to 6 years, even now, by the way, there were many implementations based on this transformers architecture. Now, when I say this, that doesn't mean everyone use the same architecture. So people used the base architecture of transformers and they added their own various components into it. Now, some of the people used only the encoder part of the transformers, some people used only the decoder part of the transformer. Some people used multiple encoder blocks, multiple decoder blocks, like that. Okay, and through that, nowadays you will also see that instead of multi-head attention, there is a term called as flash attention, so that the calculation of these embeddings will be much faster. KV cache is there, so that inferencing will be a little bit faster. So multiple components have been getting added. Okay, but these were the reasons. Now, let me know if there is any question or any doubt over here till now. Okay, transformers itself is a very huge topic, and if you blindly try to read the research paper itself, most often than not you will see like yourself getting nowhere, because as I said, the researchers themselves did not know how big of an impact it will make. So they have not explained many things in the paper. One of the thing which was not explained in the paper was this residual connection itself. Over here you can see these arrows, right? So these are called as residual connection. Means over here we are trying to add what we had over here into the next particular step. Okay, they are not explained there. So let me know if there is any question over here in the transformers architecture. I'll wait for a minute just in case anyone has questions. Questions, I guess. All right. So these were the reasons. Now, after the transformers, after a couple of months, there was another paper called as ULM Fit, okay, which actually introduced the transfer learning for natural language processing. The same transfer learning I talked about in computer vision, where you get a pre-trained model and train it or fine tune it on your specific data, and you can use it. So, but in transfer learning paper, ULM Fit, you will see that they have used traditional LSTM, not transformers itself. One of the reason could be the development of or the research was actually going parallelly for transformers and ULM Fit as well. But combiningly, these two paper completely changed the landscape of AI. Although you will hear the ULM Fit paper's name or the mention of it much less as compared to transformers, but if you see the contribution is there of ULM Fit as well, and the major one at that. Okay, so once this was done, now in 2018, the lead companies in AI, one was OpenAI and the second was your Google itself. Okay, they proposed or they built their own models. OpenAI built something called as GPT, that is Generative Retrained Transformers, and Google built BERT. And remember, as I said, many people just use a part of transformer as well. Means some use only the encoder, some use only the decoder part. Okay, so Google's BERT model use only the encoder part of the transformer. Considering when we are encoding the information, then we are trying to understand it. So it was real good at the task like sentiment analysis, text classification, summarization, where the understanding of the text was needed. Whereas OpenAI relied on their decoder only architecture, and decoder only architecture, the main reason of it was it was able to generate the new data. Okay, there were other architecture as well, like Google's T5 model, which was based on both encoder and decoder and so on. So till 2019, till as well as till 21, many of the implementations were there. GPT-1, GPT-2 were introduced. Of course, at that time, OpenAI was actually open, means open source, not unlike now. Okay, so yeah, many of the people used it as well, but the output they got was not uh, satisfactory. Now it completely changed again the landscape itself in 2022, where OpenAI kind of built their most successful model like GPT-3, and because of that, this ChatGPT application got powered by this GPT-3. and many of the users saw its capabilities, and it was quite new at that time. And that became the point where your generative AI started becoming like very popular and reached to the current popularity which you see nowadays. Okay, so now, when we consider various model types of your generative AI, there are multiple modalities. Over here, you can see just couple of them, like text to text is there, text to image is there, means you provide the text, and in return, it generates the image. There is also text to video, text to task, but nowadays there are very different modalities are there for our AI. Okay, so now you have these foundation models. Now these foundation models are nothing but the GPT, BERT, which I talked about. Now what happened was, due to the transfer learning, obviously generative AI models like these large language models. Okay, priorly also you had a concept called as language modeling. We use the term large language model just because the scale of the model is very huge. It was trained on a very huge data itself. That is why large language model term is there, but the general term is just language model. Okay, so a foundation model is basically a large scale pre-trained AI model that serves as the base for multiple downstream tasks. These models are trained on massive data set. You can even consider the entire internet data where the companies which they can get hands on. And then you use these models to fine tune on a specific application, making them versatile and widely applicable. Okay. So over here you have, let's say, a pre-trained model, pre-trained model. Okay. So this pre-trained model could be your GPT, your BERT, even your T5, could be anything. Okay. Now this pre-trained model is basically trained on the huge amount of data, huge data, where it learns to solve some specific task. In this task, you will see that generally those are next token prediction, next token prediction. Token you can consider like just a word for now, separate word, but token can be a word, a sentence, or even an entire paragraph as well. Or when we say tokenization, so we can tokenize based on words, sentences, or paragraphs as well. So these were trained to do these particular tasks, next token prediction, or sometimes mask filling. Mask filling. What is mask filling? That while giving the input data to your large language model during training, you mask couple of words. I mean, just like you have fill in the blanks. Okay, so model, you pass the data with these masks on, uh, blank blanks on, and model learns to predict what will be the word in that particular fill in the blank. Okay, and through this what it does, it understands the language itself. Okay, it understands the language itself, it gets that understanding, and using that understanding, now you can take this pre-trained model and fine tune on tasks similar tasks. And through this entire thing is called as your transfer learning itself. And through this you will see, like many of the models or companies, what they did, since they did not had access to the internet data or could not afford to build these models from the scratch itself, they took this pre-trained model and trained on their own data, did some like fine tuning or your instruction tuning. These are basically there are various methods of fine tuning as well. Okay, we'll see PFT, LoRa, QLoRa, those are their quantization basically. So these techniques are there, but nevertheless the concept is same, like taking a pre-trained model and using it to train on the other similar data so that it can learn from it. Okay, instead of training from the scratch itself. One of the reason that I said that personally you cannot train this huge amount of large language model itself. Uh, of course, if you are from the very rich family like Ambani's or stuff, you can do that. But otherwise, it is nearly impossible to train this model on a personal level, because the huge amount of data, that is one thing. Other thing, huge amount of compute. Now, GPT, the amount of electricity they needed for, I think, GPT 1 or 2 was enough to run an entire village for an entire month. That was the amount of electricity it was consumed by the GPUs while training the data. Okay, so and you also need, like, very huge amount of clusters of GPU. Later on, you will see US actually put a sanctions on their export of the GPUs as well, so that no one else like can take over them or make them fall behind in this race of AI itself. So primarily the H100 GPUs were used for training these large language models, and US basically put a sanction that a particular country, specifically at that time China, cannot import more than a particular number of H100 GPUs. Okay, so these were the restrictions, and even currently there are. Okay, so through this, by the way, GPT, BERT, T5, these were the primary models over here, which kind of set the foundation for the generative AI itself. Later on, these transformers were not only used for text data but also for image data as well. We call them as vision transformers. Later on, various architecture also came for images, specifically diffusion models. Generally, like, you will see they work much better if you want to create a new image from existing data or something. So diffusion models, by the way, work a little bit differently as compared to your generative AI models or these transformers, vision transformers. So these were the restrictions. Let me know if there's any question. So as I said, so foundation models, these are large-scale pre-trained AI model that serve as a base for multiple downstream tasks. So they are of massive scale, trained on billions of parameters and vast data sets. Versatility, capable of performing diverse tasks, be it language translation, text generation, image recognition. So various tasks they can perform. Okay, pre-trained, so developed through extensive training on general data, requiring minimal additional fine-tuning. Right now, you will also see that these major AI companies like OpenAI, Anthropic, they're building huge data centers as well, investing millions and billions of dollars. So just to, like, get ahead in this AI race. They're also reusable, so they can act as a common foundation for different applications. Some of the foundation models are GPT, BERT, T5, DALI is their stable diffusion for now. DALI and stable diffusion, these are image models, by the way, for creating images. Stable diffusion, on the other hand, doesn't actually use transformers. It is a diffusion model, okay, by Black Forest company. Okay. And now, in real world, you can see various applications of this data, not only in IT or computer science sector, but almost as long as there is a data, you will see that in that particular domain, the application of generative AI or agentic AI is always going to be there. Some of the major implementations which are happening right now is in healthcare industry for identifying any anomalies, let's say in the X-rays or MRI reports, even trying to diagnose for the primary, like, symptoms or diseases, everything. Even drug discovery, it can accelerate the process of finding new medications, which generally took around 10 15 years itself to find various kinds of new drugs. So there was one model, by the way, around 2022 by Google, called as Google AlphaFold. You can even search. It was at the time too. Right now, Google AlphaFold 3 is there. So Google AlphaFold, which I also consider major discovery, one of the major discovery or major implementation of generative AI, because it could solve the problems which require thousands of researchers to work for 5 to 6 years to find out multiple or different structures of proteins in DNAs. Okay. So for medical imaging also, you can use generative AI. Currently in entertainment also, there is a growing use, even like, many reels, many videos you may generate you may generate them through these technologies. Although sometimes it can be pricey considering the tokens are considered. Okay. Then for marketing, many companies now run their entire marketing research or marketing campaigns, which primarily consume a lot of resources through generative AI or even traditional machine learning itself. Okay. So there are the future of generative AI. If we talk about it, so currently, whatever there are three types of AI itself, considering the capability of the AI. You have artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. So currently, we're at the very first step, that is artificially narrow intelligence. So these major companies are actually having a race to achieve this AGI first, that is artificial general intelligence. Means AI can do everything a human can do. In artificial super intelligence, AI will basically go much beyond than human capabilities itself. Okay. So there are also a couple of things. Now someone mentioned hallucination. Okay. Can anyone who knows already let tell me, like, no, what do they understand by hallucination? Do you know, like, what is hallucination itself? I'll wait for a minute for you guys to answer. Yes, that is correct. Very correct. Srishti and Prasad. Uh, when we say unexpected results, we can also get unexpectedly really good results. Okay, so not exactly the unexpected result, but yeah, it produces inaccurate or fabricated information. Okay, Bram in Marathi, correct, Jayashree. So what happens is, priorly, okay, these AI models did this hallucination. So what happens in hallucination is that whatever AI model you are using, it tries to give you, or it gives you factually inaccurate result. And even if you try to tell it that no, you are factually wrong, this happened, it tries to convince you, no, that whatever it said is actually true, by even fabricating the evidences or giving excuses in a way that it will sound so legit or so, like, factual to you, that you may even, like, end up believing them. Okay. Now why is this? Now primarily, many researchers actually, like, tried to minimize this hallucination, like, various through various means and stuff. And somehow, like, somewhat they also got success in that, but they were never able to completely, like, get rid of this hallucination. Later on you will see that OpenAI also told or said that hallucination itself is not a problem, it is the byproduct or kind of like a side effect. Why they said this? Because remember, I told you that these large language models have been trained on internet data, right? And internet can be quite a scary place to be in, right? So when these people train these AI models on this huge amount of internet data, obviously they did not check whether a particular thing was factually correct or not. They just trained them. So AI doesn't really know sometimes that what it is telling you is factually correct or not. Because obviously in internet as well, many people put factually inaccurate information or things there. So that is why OpenAI said that this hallucination, instead of treating it as a problem, it is just a side effect. Because if you're going to train your models on this huge amount of data, along with these good patterns, it is also going to learn these bad patterns. Okay. So that is the reason why AI hallucinates. But over the period, now tools are being the access to tools is being given to our AI models, or RAG is implemented. So these things, because of these things, we are able to minimize the hallucination, and up to some extent we can completely get rid of it as well. So tools are kind of like simple. Like for example, let's say you're asking something to your AI model. By the way, this where there were many cases where there was I don't know which country was it, possibly Australia or Switzerland maybe. So many of the advocates, lawyers actually used AI to generate summaries or like for to use like the documents for their cases and stuff. Yeah, at that time actually it was like still in kind of initial phases, and it put the information wrong. Also like put the citations wrong. That whatever like citations it provided, that this particular thing happened in a particular case, that case didn't even exist. So a lot of lawyers got like fined or even like got revoked from their license and stuff. Okay. Now when we say these tools, it is nothing but simply simple thing can be giving it the access of internet search. So in agentic AI, also agentic AI, what we do, that we give access of tools to these large language models. These tools, for now, you can just consider them as function as well. It can be tools, it can be external APIs, and like many more. So I believe like you do have agentic AI later on as well by someone else. So at that time you will be able to get into depth in it. But when we say agentic AI, just consider it as LLM with the access of some tool. Okay. So one of the tool which we can give is internet search. So you have APIs like Tavily search. So Tavily, what it does, it provides you with an API which your large language model can access, and you can prompt your model that if it is not sure, like what is the answer to this or what is the current state, then it can access this tool and do the internet search itself. And majority of the time when you do Google search now, the information might be like very very trustworthy as well. Of course, maybe not in healthcare sector, because sometimes you put that I'm having the headache and it tells you that you may have a brain tumor, right? So might not be in case of healthcare, but you can give access to tools where these tools are used to give factual information. Another thing I talked about is RAG. So RAG or retrieval augment generation, although implementing RAG is complex for various kinds of data. Okay, the process is quite complex. The concept is very fairly similar. That you are trying to give access of the information to your LLM, which it doesn't have in the format of a document, pictures, maybe audio, or maybe any other format. So what happens is that your AI doesn't rely on its training data to give you the answer. It just relies on the document you're trying to provide or the information you're providing. That is what RAG is. Okay. So hopefully hallucination is clear to you guys. Let me know if you guys have any questions or doubt regarding. All right. Right. So hopefully all is clear regarding how the AI, current state of AI, how it was primarily and what kind of problems will make it. Okay. So this AI, considering generally the natural language processing itself, the way you interact with them or the way you get better outputs or responses from them is through prompts. So prompts is kind of like an input, just like in machine learning, you provide the input and you get the output from it. Over here in generative AI, your prompts are the input. Okay. So that is why different kinds of prompt or how you're exactly prompting your model, it will be heavily responsible for how or what kind of response you are getting from it. Okay. Sometimes people give straightforward prompts and like no AI doesn't give you them proper response and stuff, and they think that there's an issue with the model. But sometimes the issue is just those prompts. maybe somehow you may have experienced couple of things, like maybe throughout doing something, solving a particular problem, you might be telling it in the prompt itself that please bro, or whatever you call it, final time, please follow these extra instructions, don't do this, don't do that, right? To the point, like, where you become quite frustrated with the whatever AI model you are using itself. Okay, one of the primary thing is the problem will be with your prompt, or sometimes just your memory or state. One more thing I would like to tell you that these large language models inherently they don't have a concept of memory, means they do not have this memory, so they do not they are not able to remember what kind of conversation you had in the past. Okay, now you may ask, but the ChatGPT remembers it because they have introduced the concept of state into that. The LLM is just GPT 5.15 like that. And to along with this LLM, they have introduced the concept of state or memory itself so that it can retain this past conversation. But even though if you will see that as your chat goes longer and longer, it will go ahead and forget some old information as well. Okay. So LLMs themselves don't have the concept of state or memory. So now let's move towards our next part, that is our prompt engineering itself. Okay, so we'll see a couple of prompt patterns, how we can exactly get write better prompts and everything, so that you can utilize them for getting the appropriate responses. So what is a prompt and why it matters? So prompt is every piece of text you send to a large language model. It can be your instruction, it can be your context, it can be your examples and constraints. If you want to add some limitations to it, so it will be treated as a prompt as well. So think of it as the complete input that shapes the AI's response. So LLMs do not understand like humans. Okay, they predict the next most likely token based on the patterns it learned during its training. So that is why you will see the term next token prediction. Why? Because this large language model they do not actually understand the humans. Okay, they try to predict the next word possible in your particular whatever prompt you are giving or whatever uh, sentence you have passed it. Your prompt directly shapes that probability distribution. And whatever the next word predicted or however the response will be, your prompt directly shapes that particular probability distribution of the tokens, possible tokens. Okay. So nowadays, by the way, at least in the primary days, you will see like no, it will be heavily relevant or heavily in a way that it just tries to predict the next word. Nowadays you will see that over the period of years, many of the prompt techniques like many of the prompt techniques like COT, chain of thought prompting, react prompting. Okay, people understood that these are very powerful technique and they implemented in the application itself, means sometimes you don't even have to do that by yourself. Okay, also instead of fine tuning they also instruction tune those models so that they can have conversation. So you will see a lot of changes as compared to your time in 2022-23. There are a lot of changes there, but let's see when I say that it tries to complete the next it tries to complete the sentence, it tries to predict the next word, what it means. Okay. So majority of the LLMs or this chat application I use, they are like heavily you can say personalized. So it may not give you the proper response or the what I want to show you. So I'll use something which I don't generally use. Okay. So let's see. This is DeepSeek. Okay, and I'm not going to give it any kind of instruction or anything. Okay, I'll simply write. Let's say roses are red. That's it. Am I giving it any kind of instruction? No, just a simple short sentence. Roses are red. Let's see its output. So you can see it just through this roses are red. It considered it checked through its millions of words. It checked the probability distribution and bit by bit it completed the sentence. Right now you can see this extra line over here. Okay, but if you check some earlier chat applications like in 2022-23, it wouldn't have even like give this. It would have just completed this particular poem, short poem. So it is saying roses are red, violets are blue, and what comes next is completely up to you. Okay, but now you may also say that okay, if it is predicting, then will it predict the same thing for the same prompt? The answer is no. Why? Because these large language models are not deterministic. They can be deterministic, but people themselves added this non-deterministic, you can say, uh, thing or non-deterministic way over here so that you will get different output even if your prompt is same. For that you have a couple of things like p value, top k value, temperature is there. Okay, so these are different parameters which you generally see in language modeling. Okay, so let's say if I try to give the same input, okay, will I get the same output? See, roses are red, violets are blue. That's the start. What would you like to do? Okay, so you can see even though the prompt is same, the output I am getting is different. Okay, so prompt engineering basically means systematically designing prompts to get reliable, precise, and high quality output from your AI systems. Okay. Now, over here, if you give some kind of paper to your model and tell it to just summarize this paper, it will summarize it. Okay. But you will see that the way it summarizes will be much different if you give a proper instructions or proper prompt, like summarize this research paper in 3 bullet points for a non-technical audience, focusing on a practical application. So these prompts produce wildly different output quality. The second gives actionable, audience appropriate result. You can even try on your end if you do have some kind of research paper or even a book PDF. You can try with just summarize this and try it with this entire prompt. You will see that the second one, this particular prompt, will give you much better response, much understandable response from that particular research paper or that particular book PDF itself. Okay. So, a poorly constructed prompt can lead to vague, irrelevant, and unhelpful AI responses. Understanding how to structure your request is crucial for unlocking the AI's true potential and avoiding frustrating iterations itself. Okay? So, for example, one prompt could be explain AI. Okay, over here it gave you like very in detail like explanation, used very heavy words sometimes. But if you tell it to explain AI, let's say to a 10-year-old boy, okay, in 3 bullet points focusing on what it can do and one example of how they use it daily, so you'll see whatever explanation over here it gives will be easily digestible as well. Okay, will be easily digestible as well. So that is why a good prompt matters a lot. So later on, when you build any generative AI application, your own chatbot or your own, let's say, agentic AI application as well, the context you provide, the prompt you provide will be uh, driving majority of your responses as well for your model. Okay, so not just for like daily use case, but even if you want to build large scale applications, at that time as well you will need the help of effective prompts over there. Now there are various kinds of prompts, by the way. A well structured prompt contains 4 essential components that work together to guide the AI towards your desired output. One of the famous prompt technique is role or persona prompt. You basically define who the AI is. You can tell it to be an expert of IEEE reviewer. You can act as a senior research advisor and so on. You can also give it a specific task, like clear specific instruction regarding what you want to do. Like you want to analyze, you want to compare, you want to just summarize or generate. You can give it context. So if your AI model is not able to answer you, if it doesn't have the enough context, so you can provide it a context as well. Now let's see. I'll show you a couple of things practically. Now over here, when you consider your role or persona pattern over here of the prompt, many people think like you can just have it act like a particular human being. Okay, but that is not the case. You can make it act like some non-living being as well. For example, let's say I am somewhere like who is trying to learn Linux. Okay, and I don't have, let's say, access to the Linux terminal currently. So what I can do, I can tell my particular model to act as a Linux terminal so that I can actually run the queries and it can tell me or show me the specific outcome. Okay, for example, I will create a new chat. Okay, act as a so I said, I told it to act as a Linux terminal. Told it also to create some sample files and respond as a to my Linux commands. So over here you can see it is acknowledging that yeah, I will act as a Linux terminal and respond to the commands. So let's see. I'm first of all entering my command ls, which should show the list of files. So you can see nothing else. Directly to ls command is also like shown over there and its output. If I want to, let's say, make directly, so I will say mkdir, I will say test file. Created output is not showing because it just creates directly, doesn't show the output. Now, if I try to put ls, you will see test files is there. Parallel, it was not there. Okay, test files. So you can actually even tell it to behave like a hack terminal, or maybe if there is some story you may have heard, you can even tell it to act like a particular person in that story. So persona pattern is quite strong when you want to solve a specific task. Okay, so this is how the persona pattern is. Let me know if there's any question or anything regarding persona pattern. You can try it on your end as well if you think you should. All right. No questions, I guess. So another part is context. So sometimes, obviously, you want to ask some personal question, or maybe when I say personal question, it could be related to your personal environment. For example, I will create a new chat and I will ask it how many sparrows are there outside my house. Okay. Mm, in the back. So it is saying that it is a good question, but it doesn't have access to the real-time information about my specific location or backyard. So in this case, what you can do, you can provide it the context regarding it. For example, of course, when I say context, it doesn't mean you have to be very, very detailed or anything. See over here, how vaguely, I try to just explain my current environment, and it will try to approximate that what will be the number of sparrows over here. Okay. So for example, it is summer. Over here, there is a small pond in the backyard. Backyard, and couple of trees are there. Any other information we can add over here? I think this information would be enough. So let's see now. And let's say I'm in India. So now you can see it is trying to reason over here. Okay. So early morning or late evening, okay, around 16, 6 to 15 sparrows would be there. Midday, this could be 0 to 4. Okay. So it tried to consider my context and uh, responded appropriately. So these are a couple of prompt techniques itself. Now, when we say like famous prompt techniques, zero shot prompt technique is one of them. Over here, what you do, you give your model a task with no examples at all. You rely entirely on its pre-training knowledge. Now, when you say task, it could be your text classification, summarization, or something else. On an naturally for this task, you would have to train a machine learning model or a deep learning model. But since this large language model have already understood, learned many language patterns, they are able to perform well on the zero shot prompting as well. So it is quite good for well-defined tasks. The model has been seen during training. Common operations like summarize, translate, classify. Okay. Many of the researchers actually use this zero shot prompting generally in a loop to create synthesized data itself. Okay. If they need some synthesized data at that time, they can use it. So, for example, I will classify the following student feedback as positive, negative, or neutral, and I give the feedback. And based on that, LLM will be able to give you the output. Of course, it may seem quite simple, but if you consider the problems like what we had to do for just this simple task priorly to 2000, even 1890, okay, even after transformers came into the picture, it was like very many different things we needed to do just to solve these kind of problems. Okay, so LLMs have processed billions of classification examples during its pre-training itself, and it learned the patterns itself. Okay, so for example, what I will do, uh, see example of zero shot, classify following text into law, let's say fiction, self help, or biography. Okay, these are the categories labels you are given. The text I will be providing, let's say a particular biography. Whatever comes. Okay, Charlie Kirk. I don't exactly know who he is, by the way. Oh, okay, this guy. Never mind. So let's see. I will have a text. Mm, yeah. Let's try to take this one. Over here, you can see a person name as well as the word advocated. So because of this word, let's see if it gets confused it as a law or something. Okay. So I'll take this entire text and I'll put it over here. Okay. Let's see what it classifies as. So based on the content, it is biography. So that is what zero shot prompting is. That is what zero shot prompting is. Let me know if there's any question over here. Then there is also few shot prompting. Now, in few shot prompting, if you consider, think that a particular task you are trying your LLM for is a little bit complex. So at that time, you can actually provide 2 to 5 demonstration examples, basically input and output pairs. So kind of like a zero shot prompting itself, but you provide more information over here, more examples before you actually query. Your model recognizes and continues the pattern called in context learning. Key advantages over here: you do not need any training, no gradient update required, nothing. Model just adapts within a single conversation, and all of the thing required over here is just for inferencing, nothing else. Now there is a rule of thumb as well, like 3 to 5 diverse, high quality examples beat 10 mediocre ones. Means instead of providing it 10, 15 examples of, let's say, very simple, like patterns and stuff, try to put 3 to 5 different and diverse high quality examples, so it learns diverse pattern in that and will be able to help you much more better. Okay, quality matters more than quantity over here. Now, for example, let's say classification. You provide the abstract like convolution filter applied to retinal scans and stuff. You call it the domain of medical imaging. Means based on the abstract, which particular domain it is. So the same example, kind of like a same example, like based on the text, we wanted it to classify law, biography, and stuff. Similarly, over here you just give multiple examples. That is your few short prompting. That is a few short prompting. Also, you have chain of thought prompting. Now this is one of the big one and very popular one. You will see that even people who build these large language models and algorithms, sometimes they themselves were not able to answer or reason that why a particular outcome is coming the way it is coming. Okay, that is because all these models are kind of like black box. Means what is exactly happening inside. It is very hard to tell, very hard to configure. Okay, so researchers actually found out that through various like prompting techniques and stuff, chain of thought prompting give you much better result. Now over here in chain of thought prompting, what you do before using it, you instruct the model, okay, for solving a particular task, and you also give example over here. But instead of directly providing the answer, you uh, tell the model the extra information regarding the reasoning behind that. So you instruct the model to reason step by step before giving the final answer. And because of this, what happens is it forces immediate reasoning tokens that help the model work through the problem rather than guess. Means what happens generally, model tries to check in its training data, right? And in training data, sometimes uh, the complex problem, if maths or coding is there, so it may not like properly give the answer. Generally for maths or some complex like examples. So you tell the model a question, and instead of directly giving the answer, you tell it the steps to solve it. So these steps becomes the reason. So that is also why we have chain of thought, chain of reasons itself. Okay. So for example, if zero shot COT is there, uh, you like add let's think step by step. If not, it generally converts it into the chain of thought prompting pattern. If few shot is there, then you provide example showing the full reasoning itself. You don't just tell the model to let's think step by step. You provide those thinking steps themselves. Okay. In 2022, you will also see landmark result. Simply adding let's think step by step improve the LLM math accuracy by 40% across multiple benchmarks. Okay, so that is why later on people thought, researchers thought that instead of relying on users to actually use chain of thought prompting, why not we ourselves introduce it in our chatbot application. Okay, so they integrated this COT in their chatbot application itself, that before model, like before it answers you, it tries to think clearly. So for example, now you may also have heard the word reasoning model. Okay, so these reasoning models, those are very similar to our thinking or chain of thought prompting itself. Okay, so if I do deep think, uh, can you explain neural net to a 8-year-old? Okay, now once I turn this deep thinking on, now model will try to think step by step before answering. So in deep seek, you can also see this thinking. Okay, so it thought we need to explain neural network for 8-year-old, use simple analogies, avoid jargon, compare to brain learning from examples like recognizing animals or toys. So over here, you can see the thought process itself. Okay. Of course, the query itself was quite simple. If the query were to be complex, you will see the thought itself would be very, very huge. Multiple steps would be there. But that is what your chain of thought prompting is. Now, these are a couple of more useful patterns, by the way. So these reusable patterns from your personal prompt library, you can apply them across different domains and task itself. So persona pattern is something like you can act as a strict but fair PhD thesis examiner, review this abstract and stuff. You basically tell your AI, your model, to act like a particular person. You can also, and also one more thing you'll see, that large language models sometimes like try to talk a lot, giving you like an extra thing. So sometimes if you want to limit its response or limit its response in a specific pattern, at that time you can use this template pattern. So you can use something like fill in the structure, objective, methodology, expected outcome, like that. So for example, if you're writing a paper, you're taking help of it, you can like tell it to whatever response it is going to give, follow this particular structure itself. First give objective, then methodology, then expected outcome, and so on. Refinement pattern is there. Now in refinement pattern, what happens is you generate the outcome, you critique it, means what is the improvement necessary, and LLM improves you in step by step manner. So refinement pattern is generally like focused towards getting better outcome throughout the whole conversation instead of just with one pattern. Okay, chain of verification is there, flipped interaction is there. Flipped interaction is also very good if you want to like trying to learn couple of things or a new concept. Basically ask the question to understand my research problem before suggesting a methodology. So in your case as a student, what you can do, let's say you want to understand a particular topic, you tell your LLM or chat application that explain this particular topic as, let's say, a particular faculty or particular researcher. And after explaining, ask me a question to check my own understanding regarding this particular topic. So over here, what is happening? Instead of you asking the question, LLM is going to ask you the question at the end of your response. So that is what flipped interaction is. Then there is also very important one, root or system prompts. So this root or system prompts, these are the hidden instruction that shapes all responses in deployed applications. So what happens is these large language models obviously are trained on the huge amount of data. So, but let's say if you try to ask it a sensitive question, some illegal thing, maybe how to build a hydrogen bomb or even nuclear bomb, or help me murder a particular person, something like that, okay, along the lines, you'll see that it will outrightly like tell you to get some help, or like to not do this, or tell you that its guidelines doesn't like support these kind of things. So that is because on top of these LLMs, people have put the guardrails. These guardrails in the form of root or system prompt are much more like there. So in root or system prompt, you basically just like in persona pattern or refinement pattern or any other prompt, you tell your model the instruction. In root or system prompt, you also provide the instruction, but over here the priority will be much more. Okay, priority. Your model will be giving priority to these instructions over any other. Okay, so when you're building your own application, and you want it to follow some strict rule. And when building the application, you will be using raw LLMs generally, so not fine tune or anything. So at that time, if you want to limit its responses or something, so at that time you have to utilize this root or system prompts themselves. Kind of like sometimes, by the way, you will see that in production across industries nowadays, people or these industries trying moving towards their in-house, you can say large language models as well. That instead of paying to these big companies, OpenAI, Google, they want their own large language model to use in their company. And that's why you will see they are also investing in a lot of resources, fine tuning of LLMs and stuff. So sometimes it becomes very sensitive that people think, okay, fine tuning hi to karna hai, right? But things like, giving wrong information, sometimes using inappropriate language. There was one use case with a fellow colleague, which I got to know recently, that the model which got fine tuned, which they fine tuned, actually started recognizing a normal, like, speech, normal conversation as bad words itself. Okay, so this kind of things matter a lot. So that is why AI, ethical concerns are there. Okay, so yeah, so these are the prompt patterns we can see. So in short, for summary, you can use zero shot for simple tasks, few shot for pattern following, COT, chain of thought prompting for reasoning. The strengths are there, like faster, cheaper, no training is needed for prompts, because when you're giving simple prompts, no training is happening, only the inferencing. Okay. There are also limitations, as I said, kind of hallucination. It struggles with deep domain knowledge, output consistency at scale, or when base model is too small. When we say deep domain knowledge, that means even though on internet many things are there, but if you are working in the field, like, in very very core of it, so that particular knowledge your LLM is not able to, like, utilize properly. When prompting isn't enough, now, as I said, fine tuning is there. So if prompts are there, then why even fine tune? So we can use fine tuning when the task needs domain knowledge, deeper domain knowledge. The model wasn't obviously trained on, and output consistency at scale is required, or the base model is simply too small. Okay. So yeah, let me know if there are any questions throughout, like, about the foundation of AI itself or this prompt engineering itself. Okay. So yeah, let me know if there are any questions. uh Transformers are better or these? Now, both of them, like, completely solves a different problem. Same, but the way they get trained is different. Okay. You will see that GANs are generally, like, a little bit more efficient as compared to your vision transformers. Even diffusion models, which I talked about, those are also sometimes are more, you can say, hectic, or more, there are more learnable parameters in diffusion models as compared to your simple vision transformer as well. So choosing transformers or GANs, that majorly depends on your use case, like what what is the quality of the images you want to be generated, or even how much compute you can utilize. Because even though you're using ChatGPT and stuff, right, behind the scene, a lot of compute is getting exhausted. And that's why you'll see currently, recently, all these companies are actually charging a lot for their tokens as well. Because when you're giving the subscription, when enterprises take the subscription, at that time they have to charge per million token. Okay. And if they are increasing the price of the tokens itself, so obviously the price of, like, completing the project itself will become very very huge, even if you're replacing, like, or downgrading, or decreasing the workforce. Like, if 10 instead of 10 people, you are saying, okay, just let's take 3 people with AI. So even with that, like, the cost will be huge. Okay. So it depends on your the quality you want, the amount of computation you are able to, like, utilize. Based on that, you can decide whether to use transformers or GANs, or even diffusion. But comparatively, transformers will give you better outcome as compared to simple GAN architecture. Okay. Any other question or anything? Feedback link, I think, will be sent by ma'am along with the one quiz as well. Okay. So good luck for that quiz as well. Almost everything which we have covered will be there. Okay, in the quiz. Yeah, you're welcome. Let me know if there's any other question or doubt. Right. If there are no questions, that will be it for from my side. I enjoyed the interaction as well, by the way. I can see lots of curious minds. So yeah, hopefully you guys enjoyed the session as well. Short, but yeah, I tried to cover as much as possible. So thank you everyone, and have a great evening ahead as well. Over to you, ma'am, just in case you want to address them. Yes, thank you.
Thank you, sir. It is a really informative session. We got technical information about GANs and transformers, which to use when, and prompt up about prompt also. Now, I would like to request Sonia ma'am to say a few words for vote of thanks. Sonia ma'am, are you there? In between, if any participant want to share their opinion about the session, they can share.
Yes, any questions from the participants? Good evening, everyone. I'm Professor Sonia Dhotre on behalf of Keystone School of Engineering. Propose a vote of thanks. I express my heartfelt thanks to today's speaker, Mr. Aditya Thakare, for the informative and engaging session, including very interesting topics like current state of AI, large language model, prompt engineering, that is the art of talking to AI precisely, giving the prompt through the DeepSeek, zero shot prompting, and the useful prompt patterns, and many more. I sincerely thank to our director, Professor Yashodan Soman sir, Principal Dr. Sandeep Kadam sir, management team, entire FDP organizing committee members, and all the participants for making day one successful. Kindly submit your feedback through the provided feedback link, which is in a chat box. Now, please turn on your camera for the group photo.
And request to all participants to turn on their camera.
Okay, we will meet tomorrow on the same timing. Tomorrow is the day 2. and thank you for all.
All of you can leave the meeting now.